Here we are. We are all so for our viewers at home, in Accelerated Algebra 2, we have always, with our little recorder thing, there's a countdown. It goes 3, 2, 1, if it's going to work, but it doesn't always work. Sometimes it takes me like 17 tries to get it to work. So because everybody has a copy of the notes already, so we all know what we're doing today. So while we were waiting for the countdown, everybody was just on edge. And when we saw the numbers going down,
we were all angry.
You didn't hear it, but they were angry. They were very, very angry. It's cool. We will get through this together. Deep breath. All right, here we go. The denominator of a fraction, let me review my notes for a second. The denominator of a fraction is 1 less than 4 times the numerator. When the numerator is... Underhill is crying. Okay, when the numerator... Let's just throw it on out there. Okay, we're all about to lose our sanity anyway.
Over.
Okay. When the numerator is doubled and denominator increased by 6, the resulting fraction is 2/5. Find the original fraction. Here's how we're going to start. Do we know what the numerator is? No. So let's say, let x equal the numerator of this fraction. Okay. So you all can see that. All right. So, okay, that's the numerator. Numerator is on top. Okay, it says in here the denominator of a fraction. Michael, stop talking. Oh, yes, on camera. Okay, this is the original fraction. We're going to do something to this fraction to get a new fraction, right? Okay, so it says in here the denominator of a fraction is 1 less than 4 times the numerator. If the numerator is x, and we know that the denominator is 1 less than 4 times the numerator, how can I write an expression for the denominator, Chaz?
4x minus 1.
Excellent. Everybody give it up for Chaz. All right. Okay, so that's the original fraction. It then says when the numerator is doubled, so this is the new fraction, when the numerator is doubled and the denominator increased by 6. So, can somebody modify this numerator for me to reflect the whole numerator is doubled thing? Jared. 2x. Everybody give it up for Jared. Then,
wait.
What?
If it's doubled, wouldn't it be x squared? Why would it be 2x?
Well, you tell me. What is 4 doubled?
8.
What is 4 squared?
Got it.
Okay. So now, the denominator is increased by 6. Katie. Good, 4x plus 5. So she took this one and added 6 to it, and then combined the like terms to get 4x plus 5. Everybody give it up for Katie. All right. Then it says the resulting fraction equals 2/5. So this new fraction equals 2/5. That's what this is saying. So from yesterday, let's write this down here. 2x over 4x plus 5 equals 2/5. So from yesterday, how did we go about solving these kinds of problems? Michael?
Cross multiplication.
Cool. Everybody give it up for Michael. All right. Somebody tell me what we end up with. What do we end up with here? You can distribute as you go. So somebody tell me what we end up with on either side. It doesn't really matter. Lydia.
4x equals...
So you're multiplying 2 times 4x plus 5?
So 10x equals 8x plus 10.
Cool. Everybody give it up for Lydia. Okay, how do we solve this for x? Somebody lead me through. Kendra? Minus 8x, okay. 2x equals 10, and then the last step, Kendra, is to do what? Divide by 2. Everybody give it up for Kendra. All right. Now let's go back. We always want to go back with word problems and see if we did what we were being asked to do. Did we do what we were being asked to do?
No.
No, we solved for x, so that's good. How do we use that to find the original fraction?
Plug it in.
Plug it into what?
To the first problem.
The first one. The original fraction that we set up was x over 4x minus 1. So that's the original fraction, or orig frac. I am so tired. Okay. It honestly will be a miracle if I make it out of this school year alive.
Ditto.
4 times 5 is 20, minus 1 is 19. Is anyone else feeling that way?
Yeah.
I gave up last week.
Yeah.
You gave up less. Oh, that's right. That was this class that we all gave up.
Yeah.
Okay. Questions?
Wait.
The end of the problem. Next.
Wait. How did she just do that?
Okay. Hang on. Let me put it back up here.
Oh, got it. I got it. Jonah explained it to me.
Okay, you good? So you just take. All right, everybody zip it.
Back into the original.
For our viewers at home, you guys are all so quick that I'm afraid the viewers at home did not get what just went down
It's okay.
on this paper. It's okay.
Be in
Let's
class.
not leave other people behind.
Be in class.
We don't care about this. Turn it up.
Yeah.
That's true. As teenagers, you only care about yourselves. That is definitely clear. Okay, here we go.
Oh, wait.
Ready? Maurice's checking account now contains $40 more than Bob's.
Original name.
If Maurice, we actually have a monkey at home that my husband has had for a really long time. It's like one of those toy ones.
I thought you had like a real.
Not a real one. You can like make it like cheap when you. It's the name of the monkey. He gave it a name for our daughter to play with. He named it Maurice.
Why?
Maurice the monkey. I
What
do
is
not
the
know.
backstory?
Yeah.
I don't know the
Tell us the
backstory, actually. It's a good question. Okay, if Maurice made... I would love to have a pet monkey, though. They are so cute. Don't you guys think?
Yeah.
A monkey as a pet?
We have a class monkey.
I would love that. That would be awesome. All right, here we go. Let's get back to this. So, back to Maurice and Bob. Okay.
Maurice.
If Maurice made an additional deposit of $26, the ratio of their accounts would be 8 to 5. Okay, so now and then after the deposit. This is actually really similar to what we just did in the last problem. We're setting up, so because they're talking about a ratio here, that's another way you can express as a fraction. Okay, so we want to set up a ratio to express Maurice's balance in his account over Bob's, or Bob's over Maurice's. It doesn't really matter. So let's say that X is the amount, the amount in Bob's account now.
Why Bob?
Oh my god.
This
Okay,
What about Jade?
so if we do you got anyone have a preference as to whether we put Maurice on the top of the fraction or Bob?
Jade. We should put Jade.
We should put Jade on the top.
This paper
It's
checks this.
it's
there's no
easier.
word on it.
It's Jade. Okay. Let's put Bob on the top.
Even
Bob
equal
over
rights
Maurice.
too.
Okay. So we just said that Bob's got X amount in his account. It says here that Maurice has how much relative to Bob? Michael.
40 more.
40 more. How would I express that in terms of X?
X plus 40.
Cool. Everybody give it up for Michael. Okay. Okay, if Maurice made an additional deposit of $26, so Bob still is the same, but Maurice makes an additional deposit of $26, so we take Maurice's account and add $26 to it. What's the amount in Maurice's account after the deposit?
X plus
66. Good. The ratio of the accounts would be 8 to 5. Now, a lot of us would look at that and go, okay, so this is equal to 8 over 5 because it says 8 to 5. Is that right?
Yeah.
No.
The people who said no are correct. Why? Somebody give me some logical reason why it should be flipped around. So 5 is on the top and 8 is on the bottom.
Bob's got left.
That was good. Bottom. Okay. Michael, go ahead.
Well, because X is less than X plus
Good.
66, so we know that the 8 corresponds with the X plus 66.
Excellently put. So he said, everybody give it up for Michael. Okay. Between the two numbers, 5 and 8, 8 is larger, correct? And between X and X plus 66, X plus 66 is larger. So the 8 should go on the bottom, the 5 on the top. You guys want to use that kind of thinking when you do some of your problems tonight. All right. Nathan is Underhill is very excited about doing the homework tonight, I can tell.
Yeah!
Okay.
Woo.
So, How do I solve this now that I have this wonderful proportion set up? Cross multiply. All right. So we get 8x equals 5x plus 330. Then what? How do I go from here? What do I do? Rachel.
Subtract 5.
Good? Everybody give it up for Rachel? 3x equals 330, and then what? What do we do next? Taylor. Divide by 3. Divide by 3. Good. X equals 110. Everybody give it up for Taylor. So,
I felt like that made sense somehow. I was like, oh yeah, that's what you mean.
okay, so, did we figure out what we were supposed to figure out? No. What were we supposed to figure out?
Well, we're supposed to figure out something else, aren't we?
How much is in each account? Okay, everybody zip it. Everybody zip it. Video. Okay. What do I do next? So, I found what X is. X represents the amount in Bob's account now. How do I use, we're supposed to find how much is in both Bob's and Maurice's account now. So, X, we found one of them. That's Bob. Bob's account.
I feel bad for Bob.
It's $110. How do I find Maurice's now that I know what Bob's is?
You add
Plug it into what?
66.
The amount now, which is X plus 40. Is X plus 40, which is 110 plus 40, or 150. Make sure, so one of the things that has consistently happened on this assignment in previous years is that because we spent some time putting it back in the fraction, like on the last problem, people think they always have to put it in the fraction. You don't have to do that. Just do what they're asking you to do. They're asking how much is in each account. That doesn't mean necessarily put it into a fraction. Okay? Questions? That was not that painful, was it?
Yeah, it was.
Yes, it was. Oh, well, that is too bad.
Wednesday.
It's Wednesday. All right. Everybody get going on your